All right. Are you ready, Sherry?
Yeah.
Sweet. Okay, so Bandit, stop. So for question 3, all you have to do is go to the normal probability applet and put in the z-score of 1.358, and then you highlight the sides. And we got the area was 0.175. So that one was
Can you hear me?
simple. Yeah.
Are we on the first question? I guess I wasn't plugged in all the way and I couldn't hear you guys.
Yeah, that was question 3 is 0.7175. So 0.175.
Yeah, that's what I got.
Okay.
That's also what I got.
Question 4, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? And I got B.
Mm-hmm. That's what I got too.
Okay.
B?
The distribution of the sample means X.
Okay, I just want to make sure, because sometimes I put them in different order.
Which of the following results implies that the spread in X bar decreases as the sample size increases? Okay, so look at that again. Which of the following results implies that the spread in X bar decreases as the sample size increases? That would be the law of large numbers, right?
The sample size is large and the sample. Yeah. The law of large numbers is if the sample size is large, then the sample mean goes to the population mean. So mean decreases as the sample increases. Is it that or the normal distribution?
The central limit theorem, the more evenly distributed it will be. So I think it's probably the central limit theorem.
Except the central, let me see. If the sample size is large, mean will be approximately normal. I think the central limit basically says that if the sample size is big, which this would be the sample size increases, then the sample mean approximately normal. The spread in the mean decreases.
What we can do too is, since we all have 2 times to take it, we can all put in what we think too if there's disputes. So yeah.
What do you want to do?
I thought it was the law of large numbers, but I could be wrong, very easily wrong. Stop.
I think it's the law of large numbers too. That's what I think it is. But I don't really know.
But Cammie, like I said, we can all, if you want to try the other one, I can turn mine in first and we'll see. If I get it wrong, then you can, yeah.
Okay.
So that's what I like about the 2 times is we all get, if we.
It's awesome.
One, especially with the multiple choice, if we all turn in one, we'll know for sure.
Well, according to the lesson, it says the law of large numbers states that if the sample size is large, then the sample mean will typically be close to the population mean. This happens because the standard deviation will get smaller. What was the question?
Okay, so that's what it is. It's because the question is which of the spread in the mean decreases as increases. So I think it's the law of large numbers.
Then,
All right. So just move on to the next one then. Priya?
Yeah, sure.
Okay. The scores on the quantitative portion of the GRE are approximately normally distributed with the mean equals 150.8 and the standard deviation equals 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score?
So wouldn't we take 160, which would be the score, 150.8, right?
Mm-hmm.
So that would be the mean. Or 8.8, which is the standard deviation.
Mm-hmm.
Which 2/8, which would equal 1.04545.
Yep.
What is it saying we have to, is it 3 decimal places? So
Yep, so it's
1.5. 1.045.
Yep.
I want them all to be that easy.
Here's hoping, right?
I know. A dream, huh? Is that what you?
All right. We good for 7? Okay. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE?
So we have to do the same thing, but we have to minute. So wouldn't we? So 160. We do. Right. It's probably around this. Oh, so we would just put the applet, right? No, I don't have the applet at this sec. Wouldn't we put the G score from numbers or the Z score from number 6 into the applet?
Yes. I think. 0, 4, 5. All right, let's see. 0, 1, 5. And that would be 0.148.
keep muting my microphone. Too used to that. Just talking to myself over here.
Oh no.
Okay, but then it was is more than.
Yeah, so it would be the shaded to the right, just the right side. Sarah, did you get 0.148?
Yeah, I'm trying to. Sorry.
No, you're fine.
Yeah. Yeah, I got 0.148.
Awesome. Okay. Question 8. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these students' scores?
I don't know how to do that.
So you just add them all up and then divide them by the number of the numbers you added. So
I like to come up with the mean. To come up with the mean. Is that what we're trying to do? Okay.
I got 160 on that one.
Yeah.
Okay, but it says, what is the z-score? Z-score.
Since it's 160, would it be this? No, it wouldn't be.
So, yeah, so we must be supposed to do something with this. Oh, would we take 60?
There we go.
I mean, okay, how would we come up with the z-score? What would be the variable? Saying, well, let's go back to the, what is the,
GRE. Yeah, we can go back to the.
so would we do 160 minus 160 over 5? No, what's the standard deviation? Oh, I think we have to. Oh. Okay, so wouldn't we do 160 minus 1.8, which is the mean, over the standard deviation, which is 8.8, and then over the square root, there were 5? Is that making any sense?
Yeah.
So, okay. So it'd be 160 minus 150.8, and then over, which was the standard deviation with the square root of 5, because it was a sample. Does that sound right, you guys, or am I totally?
No, you're right.
I'm pretty sure you're right.
I love this confidence. Might not be warranted, but. How far are we supposed to round? To 3 again? Yes. So I got 2.338. What did you guys get?
What was that equation again that you were?
I did 160 minus 150 over
Sorry, you're kind of
8.8 and then the square root of,
you're just breaking up a little bit.
Can't
You
hear
said
me?
160 minus what?
150.8
Oh, okay.
over 8.8 and then the 5. So you divide 8.8 by the square root of 5. But I don't know if that's right, you guys.
You wouldn't divide it, you would times it, right? Because it's just 8.8 times the square root of 5 underneath.
I think it is times.
Oh, I thought it was divide.
Maybe you're right.
Is it divide? I'm pretty sure it's times it.
Yeah, let me look at my homework. I don't know. I think it's divide. That's a hard thing, everything and all this stuff we've studied. It's like, where is no, it looks like
It is divide.
Yeah, the person 7, number 2 says, what is, it's what?
It is divide, sorry. I was looking at the wrong formula here.
Oh, that's okay. So I don't know.
160. Divided by 8.8 divided by.
All right. I don't know about you guys, but I got 2.338.
That's what I
That's
got.
what I got.
Yeah.
Yeah, that is the right answer.
I don't know how I keep muting myself. But yes, 2.338.
Is that what you got too? Chase?
Yes.
Yeah.
I
Okay.
don't know if you heard me before, but I was and stuff, but we all figured that out.
Okay. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So,
So we just put that in the applet?
right, yeah. And it is 0.0097.
That's why it wants around 4 decimal places.
4.
So,
Okay.
Yep.
Does it say 4? Yeah. Oh, yeah. So point, I got point. Is that what you guys got?
0097.
Okay.
What is the shape of the sampling distribution of the random variable x bar, which represents the sample means of the 81 students who are selected? The normal, because there's 81.
Yeah. Yeah. That's what I think. 30, right?
Yeah.
Okay.
What is the mean of the distribution of sample means for all possible samples of size 81 that could be drawn from the parent population. Did I miss something? Oh, I did miss something. Suppose the GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that the distribution is less skewed. A random sample of n equals 81 students will be drawn. What is the mean of the distribution of the sample means for all possible sample size 81 that could be drawn from the parent population?
Okay. Wouldn't the mean be the same distribution? So wouldn't the mean stay the same?
Suppose the mean.
I'm not sure.
Okay, let me see. What is this?
Yeah, it would be 3.5, right?
Yeah, that's what I think. It would stay the same because
Yeah,
it's a
so that
normal
is
distribution. So other this change, but the mean would be the same, I think.
Yeah.
okay. What is the standard deviation of the distribution of the sample means for all possible sample sizes of 81 that could be drawn from the parent population? What is the standard deviation? The standard deviation is 0.7. Wait. What is the standard deviation? Okay, no. Oh, so it's not just the standard deviation, it's the standard deviation of the sample means.
Right, but how do we figure? Oh, yeah, I don't know how to do that one either.
Let's see.
So the standard sample means.
So
So would we just solve for the standard deviation?
of the sample means, yeah.
So do 81 minus. Oh, do we need? Okay, I did something wrong. I don't know how to do that one. How are you guys doing that? How are you setting it up?
Wait, hold on.
I have no idea. I don't even remember going over that.
Yeah, I don't know either.
I think I used the answer that they gave you, the 0.7.
What is the standard deviation of the district sample mean?
I don't know what the equation for that would be.
Yeah, I do that.
Let's see.
It almost feels like we have to do the regular mean formula, but have to solve for the variable. These questions are so dumb.
Oh, yeah, so,
It's like, what's the mean of the mean?
oh, because we know what the z-score is. How would knowing the variable help a deviation?
So would that mean that
Wait, we know the z-score?
Well, because didn't we do the z-score? Wasn't that, what was the question before?
The
No, that
mean
was
of
the
the
mean.
distribution mean?
Oh, yeah, no, that didn't help. But we don't really need to for the standard deviation, right? I mean, how do we get the standard deviation out of that? Let's see. Yeah, how to do that.
Okay, I think I found it in the book. It's on lesson 7. It's under section 3. It looks like you just put the standard deviation over the number of sample size, the number of the sample size, and that will give you
So did you say you take the standard deviation and what?
you take the standard deviation and then you divide it by the number of sample means that you have.
Which is 81? Or are you talking about? Are you talking? Take this standard by the sample size.
Yeah. Because to define the area under normal curve, you have to use that right. I'm not understanding this example at all.
I can't hear you. What did you say, Cammie? So take the sample, the standard deviation 0.071.
Yeah.
Because that would give us 0.0086 and minus 3 decimal places. Yeah, so that would be 0.
Are you? Let's see.
I'll show you what I'm looking at in the book. Let me share this screen here. You guys see it?
Can see that.
Here. Okay.
Okay, probability. Okay, so do we have,
Wait, are we
Do
trying
we
to find the
have-
z-score, or what are we trying to find here?
we're trying, that's what I don't get. We're trying to find the standard deviation.
Yeah, this is for the standard deviation.
Okay.
So standard deviation of the distribution of the sample mean for all possible samples of size 81 from the parent population. We're not looking for a probability percentage or as for standard deviation.
So what's the standard deviation of the distribution sample means? What's the
Can you show that one more time, Cami?
Okay.
Cami, you look so much like my niece. It is crazy. So
we're doing z equals
but that would give us the z-score.
right, we don't
We're looking for the mean, is that right?
we're looking for the standard
Yeah.
deviation
Yeah.
of the
This
distribution
is
of
the
the sample
standard
means.
deviation right here.
Which one?
Where my mouse
Okay.
is. See it?
So standard
Oh,
deviation
yeah.
equals
Oh, divided by the square. That's
the square
0.07
root.
divided by the square root of 80. That's what it is. You're right, Cami. That would be it. It would be 0.008, I guess.
Okay.
That, you're right, Cami. That's it. It's the standard deviation,
81.
the square root of the sample size.
So
Isn't it the square root of? So 0.07 divided by 9. Right?
yes.
Which
That
gives
is right.
0.0077. So 0.008. Yeah, Cami, you're the winner.
Right.
That is awesome.
All right. So it's 0.00.
0.008. Thank you, Cami.
You're welcome.
I had no idea.
What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? So that we do need the z-score. Yeah.
I did 3.3 minus 3.5. 3.3 over 0.7 and then the square root of 81.
And what
So then
did
that
you get?
gives you, I got -2 over 0.0777. So it gives you a z-score of -2.574. So then I put that in the applet thing.
You get 0.005.
0.74. Yep, and I got 0.005.
Perfect.
Did you get that, Cami?
I'm still working on it.
Okay.
0.5 divided by 0.7 divided by 81 squared. I don't think I got the right answer. Like negative 41.7. So I'm off.
You want me to walk you through it, Cammie?
Yes, please.
Okay, if you did, tell me if I go astray, Cassie, but 3.3 minus 3.5,
Okay.
0.7, and then the square root of 81.
Okay.
So you're gonna, so when you subtract 3.3 minus 3.5, you get negative 0.2. And then the square root of 81 is 9. Same thing as we did in the last one. Then just divide 0.7 by 9.
0.7 divided by 9.
Mm-hmm.
Oh, there it is.
And then does that give you 0.0777?
No, it's giving me negative 2.57. Maybe it's just my calculator.
Yeah. No, you're right. That's the z-score. Once you do it, that's it. It's negative
That's your z-score.
2.574.
Okay.
Yep, that's your
So
z-score.
you just log
Yep,
that
you're right.
in and then shade the right side. And you should get 0.005.
Okay.
So just put the z-score in the left, and then since I can't remember what it asked, but we only want the information to the right of the z-score
To the
on the right-hand side.
on the right hand side.
Because what's the question? Let me see.
Yeah, just shade
What is the probability?
the right side of it, because it's going to be more
It's asking
or
for,
less. No,
right, it's
for
asking
less.
what's the probability that the mean GPA for 81 randomly selected BYUI students will be less than 3.3.
Oh, it needs to be the left
What
side.
are we on, 13?
Not
Well,
the
the next question is the exact same thing. It says, what is the chance it will be greater than 3.3?
So I
Well,
think it needs to be the left side instead of the
Yeah.
right side.
If it's less than, it would be the less. If
Yeah.
it's less than, it'll be the left
Right.
side.
Right,
So
so
I
it's the
got-
left side. You're right.
0.995.
Is 0.99 is for question 14.
Oh, that's for question 4.
Yeah. So we're for 13, it's anything less than 3.3. So it's the left line. So everything shaded to the left of the line. For 14, it's greater than 3.3. So it's everything from the left line to the right. If that makes sense.
No, it doesn't.
Okay, so if you're looking at 13, Cammie, if you put in the z-score of negative 2.574, because it says that they want to know the probability that students will be less than 3.3, then we have to only go from the left-hand line, the left red line, to the left. We only want that shaded because they want to know what's going to be less than 3.3.
Okay, so that's the one that's 0.005.
Yes.
Yeah,
Okay.
that one's 0.005. And then the next one, they want to know, what is it? What will be greater than 3.3? So unshade the left and shade the right.
And
Correct,
the middle.
you guys? Is that right? And the middle, yeah, because it's everything above. So the one, 13 was below the left-hand red line, and 14 was everything above that red line. Does that make sense, Cammie?
Yeah, but it's telling me I'm not putting in an actual number. Give me a second
What
here.
do you mean? You shouldn't have to put in an actual number anywhere.
Oh, no,
You leave the z-score the same.
when I
Go
plugged
ahead.
it into the quiz, it's telling me it's not a valid number somewhere. Hold on a second. So
Just make sure you don't have any spaces in it.
0.995 is the one for 14, yes?
Yeah.
Yep, yep.
Isn't it just 0.995?
Yeah. It's 0.995.
Yeah, that's what I got.
Okay, now it's accepting it. I think I just saved it wrong or something. Okay. Got this.
So got it? Okay, 15. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. I wish they wouldn't give us all that extra info. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boats passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is an extreme or more extreme than was observed in this sample mean. I don't know if this is helpful at all for you guys, but anytime I see probability or percentile, I know that I have to find a z-score. So I don't know if that helps you guys, but when I finally got that in my head, at least I kind of knew where to start. So I did it, the variable was 185. Where did I get it? Because it was 185 pounds was the value. So the first value would be 185 minus what the sample means. So minus the mean, which is 177.6. So I took 185 minus 177.6 over what the standard deviation was. So 26.7, and then the square root of 48, because that was the sample that that was the 48 commercial boats. Does that seem right?
1 second there. It says that the average, the mean weight is 185. That's what they assume the standard is, and the sample is 177.6. So wouldn't you be subtracting 177.6 minus 185? Can you flip those two numbers?
Let me look.
So in the bottom where it's 26.7, what do you do with the standard deviation of 48?
I square root it and then divide 26. Yep.
Okay, divide.
No, it'd be, I think, Cammie, I could be wrong, but because it says the mean weight of all the passengers is 185, and then it says the sample mean was 177.
Mm-hmm.
So I think the sample mean is what we subtract, I think. If not, we need to do it the other way around. Let me see, yeah, because it's always the sample mean is what you subtract. And the sample mean was 177.6.
Okay.
So I think the main value is 185. Do you guys have any opinion on that? Because I really don't know for sure. So I got a z-score, and then I just plugged the z-score in.
What was your z-score?
My z-score was 1.920. And then what are they asking us? What are they asking?
It was 1.920. Is that what you got?
Yeah, that's what I got.
Sweet, same.
And then what is it asking? The sample is determined. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than was observed in the sample. So
Okay, so even
What
if
was
you flip the numbers, it just turns the value of the z-score that you got negative, because I did it both ways.
Okay, so it doesn't matter then. Okay, good. So then if we put that z-score in, I don't understand what it's asking. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean.
Read the note. Read the note.
So yeah, that's what you need. Okay,
So
so
it's
as extreme or more extreme
0.055.
means that we're right. That's what I got. So yeah, I need to read all the info. Thanks, Chase. I need to remember that. As extreme or more extreme means that we are not only interested in values that are lower than the ones, but also the ones that are far away. So yeah, so it'd be 0.55, right?
0.055.
Oh yeah, 0.055. Did that make sense, Cammie?
Kind of. I don't know where you got that last number from.
So you shade.
The point.
So when you're in the normal probability applet, you put in your z-score, and then you can shade or unshade the three different parts, the sides or the middle. And so to get 0.055, we shaded the sides.
Oh,
and
just
not
the
the middle.
Not the middle.
Yeah, because if
Okay.
no, what Chase was just saying, which I had missed, is where it says note at the bottom of 15. It says note, as extreme or more extreme means that we're not only interested in values that are lower than the ones observed, but also values that are far away from the mean. So you want them on both sides of the mean, but not the middle.
Okay.
I think.
Yeah.
0.055. So is that it? So are you gonna?
So I
Okay,
turned
is that
in
it?
Yeah, I turned it in, and I got 100. So
What?
I don't know if I remember we had some sort
That's
of.
awesome.
Okay.
You got 100%?
I know there were a couple that we were a little different on, so I don't know if everybody else will get the same, but I have 100, so we can all go through them.
Do you want to, do you want to go down, Cassie, and just read what you got for each one, starting with 3?
Sure. Yeah. Okay, I will just go down in order. For question 3, I got 0.175. For question 4, I got B, or the distribution of the sample means, X bar. Question 5, I got the law of large numbers. Question 6, I got 1.045. For question 7, I got 0.148. For question 8, I got 2.338. For question 9, I got 0.0097. For question 10, we got approximately normal. For question 11, we got 3.5. For question 12, we got 0.078. For question 13, we got 0.005. For question 14, we got 0.995. And for question 15, we got 0.055.
So question 12 was 0.78.
Yes.
Okay. For some reason I had 0.008. So.
Awesome. Okay, we're plugging along. So we'll meet on Tuesday to go over like the exam, right? Or the practice or whatever. Do answers for the practice exam, the answers, so we know if they're right or wrong.
Yeah.
Okay.
Well, they don't give them to you, but since I took the class last semester, I have all of my information just on like the homework quizzes and the group quizzes.
Okay.
So
Okay.
yeah. So
So we'll be able, what I'm saying is we study, we'll be able to, as we figure them out, know if they're right or wrong.
yeah,
Okay.
we will
Okay.
be able to. So
Well, thank you guys so much.
yeah, go team. Have a good
All
weekend,
right.
y'all.
You guys too. We'll see you on Tuesday.
Bye.
Bye, Cammie. Bye, Chase.